Today we learn about benzene and its derivatives. So content of the benzene and its derivatives is physical properties of the benzene, nomenclature, then structure of the benzene, molecular formula, resonance hybrid structure of the benzene, Haeckel's rule and aromaticity, reactions of benzene, Friedel-Crafts acylation, Friedel-Crafts. Now history for the benzene. Benzene can be originated from the in 1825 by Michael Faraday from an oily film that deposited from the gas used for lighting. Faraday did some experiments and discovered that the new compound had equal numbers of carbons and hydrogens and so named it carbureted. After 9 years, its discovery, another chemist, Mitzrich, found he could produce the same substance by heating a chemical that had been isolated from gum benzoin, and he decided to call the compound benzene. Then another name is benzol. So from that benzene can be now benzene having a chemical compound with molecular formula C6H6. It having 6 carbon atoms join in a ring with one hydrogen atom attached to each carbon. Benzene is classed as hydrocarbon because it contains only carbon and hydrogen atoms. So molecular formula is C6H6. Empirical formula carbon and hydrogen. Molecular mass is 78. Percentage of carbon 93.6%. Percentage of hydrogen 6.4%. This is structural formula. Then physical state is liquid. Melting point is 5.5 degree and boiling point is 80 degree and inflammable. Now all possible structures for the benzene. So it shows the class structure, Dewar structure, atom strong structure, thiol structure and Kekulé structure. So the Kekulé structure is worldwide. Physical properties of the benzene. Benzene is a colorless or light yellow. It is liquid at room temperature. It has a sweet odor and highly flammable. So IUPAC name for the benzene cyclohexa 135-triene 135 cyclohexa. Benzene is an organic chemical compound that consists of carbon and hydrogen. Molecular formula is C6. Now the nomenclature. So monosubstituted alkyl benzene are named as derivatives of the benzene. For example, ethyl benzene. Ethyl benzene is the benzene ring with ethyl group, so called as the ethyl benzene. Then toluene. Toluene is the benzene with methyl group and styrene with benzene with common names for some monosubstituted benzenes are benzene with hydroxy group, that is OH group, phenol. Benzene with methoxy group, OCH3, anisole. Benzene with amino group, aniline. Benzene with aldehyde group, benzaldehyde. And benzene with carboxylic acid group, benzoic acid. So phenyl group is C6H5 or PH. It can be derived by loss of one hydrogen atom from the benzene. When two substituents occur on a benzene ring, three isomers are possible. They may be located by numbering the atoms of the ring or using the locators ortho, meta and para directors. So for example, 2-bromobenzoic acid. In 2-bromobenzoic acid at ortho position bromine group is present and first position carboxylic acid is present, so called as a 2-bromobenzoic acid. Then 1,3-dimethyl benzene. In that first and third position methyl group is present. Then next one is the 1-chloro-4-ethyl benzene. At fourth position chlorine is present. Sorry, first position chlorine is present and fourth position. So the fact supported for the Kekulé's formula. Molecular formula, open chain structure not accepted, evidences in favoring structure, that is catalytic hydrogenation of the benzene yields cyclohexane Benzene yields monosubstitutions product. Benzene forms 3-di tri-substituted product which can be explained on the basis of the ring structure, resonance hybrid structure, molecule. So first one is the benzene having molecular formula C6H6. So from its elemental composition and molecular weight, benzene known as the contains C6, C6 and C6 hydrogen atoms. Benzene has molecular formula C6H6 and a hexane having formula C6H12, which confirms the benzene is highly unsaturated than hexane. Now ring structure of the benzene. Kekulé suggested ring structure for the benzene. According to him, 6 carbon atoms occupied 6 corners of the regular hexagon in benzene, and each carbon carried one hydrogen atom to satisfy tetravalency of the carbon. The system consisted of alternate single and double. Second one, open chain structure not accepted. So this is the possibilities of the benzene structure, open chain, but it is not possible. CH2 double bond CH, then structure 1, 2 and 3. All these structure were ruled out because benzene didn't give usual reactions like op alkynes. Some drawbacks of the open chain structure, that is addition reaction usually given by alkenes and alkynes are not given by benzene. Open chain structure of benzene rejected because benzene forms only one kind of the monosubstituted product. Open chain structure, however, can form more than one kind of the monosubstituted product. Next evidence is the catalytic hydrogenation of benzene. So benzene react with hydrogens in presence of the platinum or nickel as a catalyst forms the cyclohexane. So from unsaturated benzene, saturated cyclohexane can be. Then second one, benzene yields monosubstitution product. In that example is ortho, para and meta substituted product form. For example, benzene react with bromine in presence of ferric bromide FeBr3 forms di and tri-substituted product. Resonance hybrid structure of the benzene. This is a resonance structure of the benzene. Stability of the benzene. So cyclohexane react with hydrogen forms the cyclohexane. Cyclohexadiene plus hydrogen, cyclohexane and benzene react with hydrogen forms cyclohexane. Having the energy